Hi, this video is going to be continuing our notes from section 9.4 on Arithmetic Series. So we've gone through what an arithmetic series is, and we know that it's the sum of the sequence of an arithmetic sequence. Okay, and I kind of want to remind you guys that we have the formula for the sum of that. So remember, the sum of an arithmetic series is n over 2 times the first term plus the last term of the series. Remember, n is the number of terms within that series. Now, so let's talk about the next thing in that section, and this is writing series in what we call summation notation. So summation notation is going to be a little bit different, but it's a good way of being able to write a series. So if we had this series 2 plus 4 plus 6 plus 8 plus 10 all the way up to 100. Okay, we would be able to write this, but summation notation gives us a different way of writing it, a little bit easier way, more concise way. Now we use the Greek letter capital sigma, which is a big E. Okay, now we also have limits. So we start with the lower limit and upper limit, and that is your n, so your terms. Now normally whenever you can write your own, it's easiest to start with n equals 1. Now with this series we did earlier on Wednesday, we found out that it took 50 terms to get from 2 to 100. So that was a sub 50. So that is the upper limit. So this a sub n, the n is 50, is the upper limit, and we would write that above that Greek letter sigma. So this is the lower limit, which goes here, and here's the upper limit. Now we also found out the explicit formula, which is the next thing of the summation notation, and the explicit formula would be 2n, and that was it from here. Okay, so 2n is the explicit formula for that expression. So this is the summation notation. Okay, we're going to do another example to get that a little bit more. So let's look at the problem 3 on page 589. So problem 3. And we want to write, sorry. So we're going to write this series in summation notation. And we're given the series 7, 11, plus 15, and that pattern will continue all the way to 207. Okay, so now the first thing that you want to do when writing it in summation notation is, we know that we're going to have the Greek letter sigma, and let's go ahead and start with the lower limit as n equals 1. Okay, so this is going to be our a sub 1. Now we need to find the lower limit, which we found. We also need to find the upper limit, which is going to be the n, how many terms it takes to get to 207. And then we need to find the explicit formula. Okay, so let's go ahead and we can find the explicit formula, or actually let's find the upper limit first. So remember, if you remember the formula that I gave you guys, we found out that n is equal to the last term minus the first term divided by the common difference, and then we add 1 to it. So using that formula, the last term is 207 minus 7 over the common difference. Well, if you look at this, the common difference we have to add 4 to each term to get to the next. So that's the common difference. So we're going to divide by 4, and then we're going to add 1 after we do that. So we get 207 minus 7 is 200, divided by 4 is 50, plus 1 we should get 51. So n is equal to 51. That is our upper limit. So we're going to put that there. Now the last thing we need to do, just to put this into summation notation, is to find the explicit formula. Again, this is an arithmetic series, so the explicit formula for an arithmetic sequence is a sub n is equal to a sub 1 plus n minus 1 times the common difference. Okay, so let's go ahead and plug those in and see what we can get. So a sub n is equal to 7 is the a sub 1 plus n minus 1 times the common difference, 4. Okay, so we distribute the 4, we get 4n minus 4, and so our explicit formula will be 4n plus 3. So this is going to go up here into our summation notation, so 4n plus 3. And so there is the summation notation of that series. Okay. Now, just real quick, I want to rehash what I found. So in order to, and you might want to write this down somewhere in your notes, take note of this. In order to write a series in summation notation, we have to find 3 things. The lower limit, which usually we can start off with 1. The upper limit, so we have to find the n using that formula. And then the explicit formula. Okay, so lower limit, upper limit, and explicit formula. And we remember the explicit formula for arithmetic series. The next lesson we'll be doing geometric series, and there will be another formula to find for geometric series. Okay, so that's it for this lesson. And there we go. Actually, April Fools. Sorry about that. I lied to you guys. We have one more example that I'd like to show you guys. Using summation notation, how we find the sum. So let's look at the problem 4 in the book. And so it asks you to find the sum of the series described by the notation. And we have sigma, the lower limit is n equals 1, and it goes to 70, of 5n plus 3. So the way that I say this is we want to find the sum, because that's what that sigma stands for, the sum of 5n plus 3 from 1 to 70. So we say the sum of the explicit formula, 5n plus 3, from the lower limit to the upper limit. So the sum of 5n plus 3 from 1 to 70. Now, remember the summation formula. So S sub n is equal to n over 2 times a sub 1 plus a sub n. Now, normally, most of the summations we're going to be dealing with do start from 1 and go up to here. So we know that the n will just be whatever the upper limit is. We won't always be able to do that. And I'll show you one more example after we get done with this where this is not the case. So now we need to find the first term and the last term, which is 70. Okay? Well, that's not too hard to do with the explicit formula. Well, the first term is we're going to just plug in the lower limit. Well, that's just 1. So we have 5 times 1 plus 3. We plug it into the explicit formula, and we get out 8. So to find the last term, we plug in the upper limit, 70, into the explicit formula. And 5 times 70 is 350, plus 3, we'd get 353. And so now, all we need to do is plug these 3 variables into this formula. So I'm going to do this real quick because you guys have been doing pretty good with that. And you already know how to do this part. So we get 353, not 36. 353. And so if we simplify that, we get 35 times 361, which will come out to be 12,635. So there's the sum of that. Now let's try one problem where the lower limit does not start off at 1. So let's go from n is equal to 3 all the way to 10. And then let's say we have the explicit formula of n plus 5. Okay, that's a fairly simple, easy problem to deal with. Okay, so again we need to find the sum, we would need the n, the number of terms, the first term and the last term. Now, you guys are going to be quick to say that n is 7. But let's look at this. If we start off at 3, we'd go to 4, 5, 6, 7, 8, 9, and 10. So we'd go from the lower limit to the upper limit, counting each of the integers. But now let's count how many terms there are. There's 1, 2, 3, 4, 5, 6, 7, 8. Well, that's kind of weird. So now, the way that we do this is we take the upper limit minus the lower limit, and then we'll add one more. So it would be 10, so n is equal to the upper limit minus the lower limit, and we're just going to add one more to it. So 10 minus 3 is 7, plus 1, it'll give me those 8 terms. So now we need to find the first term, a sub 1. Well, I'm sorry, oops. A sub 1 is not the first term. The lower limit, notice, is 3. So the first term would be a sub 3. And the last term is going to be the upper limit. So now I'm going to plug in 3 into n, and I'll get 8. And then the last one is going to be 10. So 10 plus 5 is 15. And then now I have the 3 variables to solve it. So 8 divided by 2 times 8 plus 15. And so when I go through and do that, I get 4, times, it's going to give me 13, and that's going to be 40 plus 12, 52. So S sub 10, or 8. The sum of 8 terms is going to be 52. Alright, now I'm done. Thanks for watching. Have a good day.